Hey everyone, I'm Jim Gordon, a Senior Program Manager at Microsoft, and I'm thrilled to host the November 2024 Azure Cosmos DB Global User Group. Today we're diving. I'm not driving. I drove for 8 hours yesterday. Don't even get in your car. So today we're diving into an exciting session. It's called Empowering AI Applications with Vector Search in Azure Cosmos DB. And you know what? Everyone lately, when we're talking about what's the new and good things for Cosmos DB, we keep hearing vector search and different AI focused products. So it's such a huge deal. Everybody's building around intelligent applications. So today we're going to explore how Cosmos DB's native vector support can bring advanced AI capabilities right to the database. And that's what we want. We don't have to jump through hoops. We want to use what's available right in Cosmos DB. And I'm going to be joined by an amazing guest. You may know him already, Lenny Lobel. He does so much stuff for this community. It is incredible. He's a Microsoft MVP and he's the CTO of Sleek Technologies. He's going to be with me in just a minute. But one of the things I want you to know is that we're going to be ready for Microsoft Ignite. Geez, Microsoft Ignite, it seems to sneak up on us every year in November. But don't forget. So if you want to see any of the sessions that we'll be having at Microsoft Ignite, go right here. You'll be able to get everything you need as far as sessions are concerned, and you can register right there. Cool. I'll drop it in the chat as well. Well, before we get started, I always like to bring in my partner in crime. Hey, Oski, how are you?
I'm good, Jay. How are you doing?
Great, great. So Oski always helps me do a little bit of housekeeping before our session starts. Why don't you tell us what people need to know to have the best time possible at this group?
Absolutely. Well, we definitely seek to provide a respectful environment for all of our presenters. We encourage engagement in the chat, but we ask that you be mindful of your commentary. Try to remain professional, and if you can, please stay on topic. We will be sharing useful links throughout the chat, so keep an eye out for that. And we want everyone to know, if you missed part of it, this session will be recorded and is going to be available on demand on the Microsoft Reactor YouTube channel within 24 to 48 hours after the session is concluded. So with that said, I will hand it back to Jay, and it sounds like Lenny is on his way.
Yep, we'll see you after this session. Thanks so much. We'll close it out. You'll let us know what do we need to do next, but something tells me it's got something to do with the survey.
Yeah, I think so.
Cool. See you at the end. Cool. So we've got everything. And I want to just tell you, if you want to be here, just like Lenny and all of our other previous guests, cool. go take this intake form, fill it out. I'll also be putting it in the chat. So we've got through all the little things we need to do before we actually get in the session. And I want to bring in my guest today. So joining us from the lovely, lovely land of Brooklyn, New York, where I am from as well. So Lenny, this is always special to me when you and I get to do these things. I want to welcome Lenny Lobel. How you doing, Lenny?
Great to see you, Jay. Thanks for inviting me again once more. It's always a pleasure to present for the group.
I appreciate it. And you know what? That leads me into kind of asking you, like, for those who aren't already, I guess, familiar with you, that group, it's amazing how much you've given this group in general. And I was curious if you just give me a little intro to yourself and what you've done for our community.
Sure. Well, I mean, I am a data platform MVP, and so of course with a heavy focus on SQL. But ever since the introduction of Cosmos DB in the days when it was called Document DB, going back to 2015, now 10 years, I have been just fascinated and completely passionate about Cosmos DB. I think it's an amazing platform. It's very developer friendly. I am first and foremost a developer. I'm a full stack solution architect, so front end, back end, middle tier, all of it. In terms of the NoSQL, the NoSQL offering that's provided by Cosmos DB is unsurpassed. So it's just been great. I've been doing Pluralsight courses since the early days. I have the newest one has been recently updated, so go ahead, check it out. It's 8 hours of content for a good introduction and deep dive as well. And I've been presenting at this group for now many years as well, talking about everything from introduction level topics to data modeling and microservices with the event feed, with the change feed rather. Yeah.
So one of the things that I remember, and I want to hand this over to you in just a minute, but I just want to take a little minute to brag about you for a second. So when I first came on to the team, and that's about almost 3 years, I came from another one of our evangelism teams. It was a lot of fun. Came over here. One of the first things that my leader, Mark Brown, said to me, and Mark Brown actually used to be our guest, or actually our host here. And he was lucky, or I should say I was lucky enough, he handed it off to me. But one of the very first things he did was he said, I want you to take this Pluralsight, and it was yours, around intro and data modeling and understanding Cosmos DB. And I have definitely skilled up just from taking that. So go take Lenny's course. Thank you so much for it. It's so helpful.
Well, thank you for that, Jay.
Well, we've gotten through the niceties, we've gotten through all the intro, and now it's time
to sink our teeth into the meat.
So as we go along, we're going to be taking questions. Put them in the chat. We may not get to them right away, but we will address them as soon as possible. And with that said, Lenny, the floor is yours. Take it and run with it.
Pleasure. Thank you again, Jay. Really, always a pleasure to be presenting to this group, and always a pleasure to be talking about Cosmos DB. And today we are going to be talking about vector search in Cosmos DB. And while I guess I might be making some assumptions about some existing knowledge about Cosmos DB, like some of the core concepts around throughput and provisioning and partitioning, we're not really going to focus too much on those fundamentals. So even if you're new to Cosmos DB, you ought to be able to follow along easily enough, especially since a great many of these concepts are applicable to the SQL world as well, SQL Server and Azure SQL Database. So jumping in here, just a little bit about myself. Well, I already introduced myself as in my capacity as a data platform MVP and my connection to the community regarding Cosmos DB, but I am also CTO and co-founder of my own company here in New York City called Sleep Technologies. We do consulting, and I am also a Microsoft consultant at Ernst & Young, and I've been doing this for a really long time, since '79. So seen a couple of changes, but none so dramatic as, well, not none, but it's been a while since we've seen as a dramatic an explosion in emerging and changing technologies that really change the landscape radically of our industry, as we have with AI, right? So there's a deck. You can go to this link and you can pull down this deck, as well as there will be a link there as well to the code, which is on GitHub, and I'll share the GitHub link as well. But if you go to this link, you'll get the code and the GitHub link, the slides and the GitHub link. All right, so that's all lowercase, a bit.ly link at globally UG 2024 _ Cosmos DB _ vector _ search. And with that, let's just jump right in. The session has a fairly long title. We could reduce it down to a 3-letter acronym called RAG. Many of you have been hearing this term kicked around a lot. Perhaps it's newer to some of you. So just give a quick introduction to the concept of RAG and what RAG is. RAG stands for Retrieval Augmented Generation. So this is essentially a combination or a fusion of deeply trained AI models, completion models, chat completion models like ChatGPT, as well as text embedding models, which are going to support our vector search. Combining those technologies with traditional retrieval systems, like a traditional database. Cosmos DB, let's consider that a traditional database. SQL Server is a traditional database. Basically, you run ordinary queries in that database that leverage AI capabilities. And this way, you are getting a tailored response to the data in your database that's not necessarily part of the deeply trained models that we're working against. So this is, again, like I said, it's a fusion, it's a merging of real-time data that's queried out of your database. So as your data is updated, the information becomes available from an AI chat perspective. And so all of your AI experiences are based on the most up-to-date content in your database. And what we're striving for here is to limit the AI experience to the data in your database. We don't want to bring in outside information, right? You want to provide an AI experience for your domain data in your transactional database, and you don't want you want to basically filter out everything else from the outside world. So that's a kind of a little bit of a balancing act that we're going to see how we, and there are many different ways to achieve this pattern. There are low-code solutions such as LangChain and other platforms that simplify development. I have built something from scratch, from the ground up, that's purely in C#. It's a solution that you can extend with your own domain data very quickly if you want to get up and running with a RAG POC based on your own domain data. Today, we'll be playing around with a movies database, but you'll see the solution code that I'm providing makes it very easy to plug in your domain data into this POC, into this solution framework, right? So the only dependency, therefore, right, besides Cosmos DB and let's say Visual Studio, is Azure and the Azure OpenAI resource that you have provisioned for yourself in Azure. And there are 3 types of models, right? There are 3 types of models that you can leverage. And the first one is text embeddings. This is the one that is most relevant to today's talk, because text embeddings is what enables vector search. And what text embeddings are is where you supply natural language input and it produces a vector, a set of floating point numbers that captures the semantic meaning of the natural language input. So for example, if I supply the Buttress Trail off of Mount Madison in the White Mountains of New Hampshire is a gorgeous but extremely difficult hike, I'm going to get back perhaps an array of numbers that looks like this. How many numbers are in this array will depend on the embedding model that I called to generate this. There's a small embeddings model, which will be 1536 dimensions, 1536 elements. And then there's the large model, which is double that amount. There'll be 30,072 elements. Obviously, the large model, as the name implies, is a larger model, and it has a higher density and therefore higher accuracy. But very often, the smaller models are adequate. But the point is, you're not getting back something that's human readable. And if I supplied text asking about trails in the White Mountains, I would get back text embeddings that are similar to this because it says White Mountains here. And if I vectorize text that asks about trails on Mount Madison in the White Mountains, I would get back vectors that are even more similar than that to this. Conversely, if I plugged in a natural language query looking for extremely easy hikes, then the vectors would be more dissimilar because these vectors represent a difficult hike. So we don't consume these numbers, we just store them in our database and allow our database to index them. Then there's the complete, and that's what's going to enable vector search of your data and pull back the most relevant results based on natural language queries. So without text embeddings, you don't have vector search. You could stop there, but a full RAG solution is not just going to take the raw database results that come back from a vector search based on similarity of these embeddings and just dump those results to the user in their raw form as they were retrieved from the database. You want a conversation back. You're going to want to leverage the completions API, which is like, the ChatGPT and Copilot experiences that all of us have been, experiencing recently, where you supply natural language input and you get natural language output. So we take our database results and feed them into the completions API, making sure very careful to instruct the completions API not to stray from the database results based on more knowledge that it might have than what is in our database. And then finally, there's a DALL-E model. All three of these models take natural language queries as input and produce different types of output. In the case of DALL-E, is image generation. So you could plug in an expression like a happy hiker walking along a trail in the woods with mountains in the background, and it will produce actually an image based on your description. So again, of these three models, text embeddings is the most relevant. Completions is what will allow us to give a conversational response, and time permitting, we'll see if we can play around with the DALL-E model as well. So let's focus and zone in on vector search and how that works. So I'm going to demonstrate this with the dot product metric. This is one of several different metrics that can be used to measure similarity between two vectors, and this is the simplest one. So let's go ahead and let's say I store the word human in my database, but I also vectorize it. I call Azure OpenAI and I get back these numbers that represent the word human, and that's a database vector. And I do the same thing for the word elephants. I've got two items in my database. One's human and one's elephant, and they're both vectorized. Now a human comes along and wants to run a query, natural language query. They're just searching for a person. Well, what we'll do is we will vectorize that query just like we vectorize the data in the database. And that is our query vector. So we've got one query vector and two database vectors. And then we align them up and run this very simple calculation. So an element-wise multiplication of each vector value. Sum up that into a final value, and that is your similarity score. You just compare for the larger value, and clearly a person matches human more than it matches elephant by a score of nearly 0.6 compared to a score of nearly 0.3. It's a big difference. And clearly, person is much closer to match to human than it is to elephant. If you wanted it, now of course, the database, Cosmos DB in this case, has this algorithm as well as the cosine similarity or the cosine distance algorithm, which builds on this. I don't want to get too much into the math of it, but there's a concept of directionality and angle and versus magnitude, and the cosine algorithm will build on the dot product and kind of normalize the magnitude and only focus on direction or angle, if you will, of the vectors. But this is the simplest implementation, and this actually will work in a POC setting. If you wrote C# code like this, right there is your dot product metric. The dot zip method is going to align the one query vector with all the movie vectors in the movies collection. And there's the query vector and the movie vector. There's the multiplication. There's the sum. And you can actually implement this yourself in code, as you can see. I'm just trying to demonstrate the fundamental principle of how this works. Let's see it in practice with a real demo. All right, so I'm going to jump on over to my application I've got up running, and I'm going to do a hello world demo, hit my breakpoint, and we're going to look at text embedding. So this is going to be an example where, an in-memory collection. All I have are movies. Really, all I have are movie titles. All I have are movie titles. If you look at the movie class, it has a title property and an array of floatings, which is the vector. and I haven't vectorized anything yet. So all I've got are movie titles, and 4 pretty well-known movies to hopefully make the point of this demo. So traditionally, there's not much searching that you could do on such a minimal database. Like all you've got is a title, right? You could do it starts with and ends with and a substring and a regex perhaps, and that's about it, right? But we want to enable natural language queries against these movie titles. So let's see how we can achieve that. What we're going to do is we're going to populate this vector array. So I'm going to, for each movie, and I'm just going to single step into the first one, I'm going to vectorize the text. In this case, it's Return of the Jedi. We're going to vectorize that text. And this is all the code that's needed to do the vectorization. You need to pull from your app settings config file an endpoint and an API key, which you get, right? I'm going to flip on over here to the portal so you can see it. Right here is where you get your key and endpoint, right? And reference a deployment name, and you can see that I have in my Azure OpenAI model deployments, I've created, I have 3 different text embeddings for the large, small, and there's an ADA model as well. 2 GPT models, GPT-4o and 3.5, and 1 DALL-E model. I just named them the same as the model name, prefixed with my name, Lenny. So that's the reference right here. And I'm supplying an array with 1 item in it, just the text, Return of the Jedi, and I'm calling OpenAI to get my embeddings. Now, what did I get back? Well, it looks like I got 1 item back. That makes sense. 1 item in gives me 1 item back. And that 1 item has an embedding item with 1536. There are my vectors. Or I should say that's my vector with the vector values or the vector components to keep our terminology correct. Okay, and it's 1536 elements because I'm going against the small model. It would be 30. I would be getting back 3072. I just passed in a movie title. I could have passed in a much larger payload, which is what we'll be doing in the real demo with full movie data, not just a title. But regardless, I'm still going to get back the fixed number of components in the vector. In this case, 1536 from a small vector embedding model. Just get back that floating point array and and go ahead and store it in the vector property. I'll iterate all the remaining movies. And now each movie in my movies collection has, not just the title, but also an array of vectors, enabling me now to do queries. Queries that you would never imagine that would not normally be possible otherwise, like movie phrases. May the force be with you. I'm going to make him an offer he can't refuse. Hopefully, you're familiar with most of this pop culture here well enough that if I even query about movie characters that are not in my database, these are fictitious movie characters or actual movie actor names or movie location references, Tatooine versus Sicily, right? Or genres, right? Let's single step through the first one. And I'm going to, this is the same method we called when we vectorized a movie, but now I'm vectorizing the text, the query. May the force be with you. This is the query vector. So I vectorize that just the same way. And now I run a vector search. And there's the code we saw on the slide. This is doing a dot product by doing an element-wise multiplication of each vector's values and summing them up, doing an order by and select first in order to get the most similar. What would the result be from May the Force be with you? Return of the Jedi. That makes sense. Let's run through all the rest of them. This should make that light bulb go off in your head about how the power of these embedding models, because all of these are producing the correct results. I am matching with the correct movie, whether it's just a phrase, a fictitious character, an actor name, a fictitious location or a location in the movie, or the genre, and I'm getting back all the correct values. So that's part 1, right, of the Hello World demo. Now, I don't want to just dump these results in their raw form. I want to present some sort of conversational response. Let's look at the completions demo for the chat completions API. Like the text embeddings API, you need an endpoint and a master key. There are some knobs and dials that you can adjust here to control the completion, or I should say the natural language response. There's temperature, penalties, likelihood of repeating new words or introducing new topics or being more creative or more deterministic. These are all knobs and dials that you can adjust. But the most important thing is, of course, the deployment model, which I'm using the GPT-4o model. And I'm going to ask and answer several questions here, like provide a summary of these movies, assuming that these came back from the database and all I have are the titles. And when I step in, right, all I'm doing is I am appending each question to the messages collection. Right now, it's just the first question. Let's go ahead and wait for its response. And depending on how verbose the response is, it can take a few seconds. We got our response. We'll display our response. And here it is. Right? All I had provided with these titles, but I got embellishment from the GPT model. Like it is embellishing on the 4 movies that I supplied. Now I'll do the next one. Only show the movie titles. Now I'm not repeating the names of the movie. So every one of these calls is stateless, but we're able to present this kind of illusion or conversational experience that makes it seem like there's memory. Because now I'm stepping into the same method as before and I'm appending to the same messages collection. So that my messages collection now has 2 messages in it. The first one is lists the movies, and the second one simply says only show the movie titles without repeating the movie names, because maybe I don't want the GPT model to embellish on what came from the database. So I'm saying only show the movie titles, and I'll let it go through all the rest of them as well. So it only shows me the movie titles. Now I might say, well, go back to showing the full descriptions and like really embellish, include additional movies that I might like beyond the 4 movies that I mentioned, which is something I don't want in my RAG application. But I'm just kind of showing you here how, depending on the way you prompt the model, the response will be embellished from your database results or limited strictly to your database results. So here I gave these 4 movies, but I asked it to embellish, include additional movies that I might like, and it just went ahead. Now I'm saying, okay, go back to showing a summary of just the movies I asked about, no additional recommendations, so no more hallucination, right, beyond what's in my database. Translate it to Spanish. Right. So this gives you an idea of what you can do once you get your database results back from your vector search and present it back as a chatbot response. Okay. So back to the slides, and then we'll have demos the rest of the session through. Don't have that many more slides. Just want to get through, like, I just did something in a very primitive way. I just showed vectors with an in-memory collection. We're working with a database. So how do we store vectors in the database? So if you're familiar with Cosmos DB, you know that you have container properties when you create a new container that will usually have an indexing policy. But now we also have a vector embedding policy. And this is declaring, if you will, or defining the fact that we are going to have a vector property path that's going to store our vector values, 32-bit floating point numbers using the cosine function. So there's dot product, like I showed you, and then there's cosine, which will normalize the magnitude. And that is the most common and generally recommended distance function. There's also Euclidean. Each of these have their special purposes. But if you're just getting started for general purpose use and you want to just get started, go with cosine. And since I am anticipating to use the large text embedding model where I need to accommodate 3072 vector values per vector, I'm declaring that there as well. Now you could stop there and not define an index for the vector, but that of course would not scale. It would be a sequential scan, and it would be scanning the vectors that are in the documents and not in some sort of specialized or optimized index. They're an index that's optimized for performing these. Well, these are that's a big set of calculations. Like all the vector component, all the vector elements have to be multiplied, and then against like a potentially very large database, you want this to be an optimized process. So there is the brand newly unveiled DiskANN, disk approximate near neighbor indexing algorithm developed by Microsoft. This is a very advanced and very sophisticated algorithm that that relies on SSDs. So they are like as fast as memory, even though they're persisted to disk, if you will, disk-based, if you will. And it's a graph-based, very sophisticated. And the thing that I'm not understanding about indexing when it comes to vectors is it's very different than traditional indexing, even in Cosmos DB. Usually, the absence or presence of an index will never have a bearing on the results that you receive. It'll only have a bearing on the performance of receiving those results. Like, you're never going to get different results whether there's an index or not. You just might wait longer if there's no index than if there is an index. With vectors, there is a compromise. There is, when you use disk-ANN, there is compression. These vector values get compressed for optimization, but in a manner in which accuracy is reduced so marginally that it's almost imperceptible. So there's a very sophisticated and advanced vector indexing mechanism that you don't really have to understand the internals of. I certainly don't know it much deeper than I've explained it thus far, but it's there for you to leverage. And then you would, of course, get your vector data embedded right inside of your document. Like I said, an optimized, potentially compressed version of this will also be in the disk-ANN index. And that's if you're using Cosmos DB for NoSQL. If you're using Cosmos DB for MongoDB vCore, which I should note is where this all started. This actually started with the MongoDB vCore API for Cosmos DB. That's where vector search started. Then it came to NoSQL with disk-ANN. It's a similar concept, though, and you create a new collection rather than a container, as it's called in MongoDB terms. You define the index type. We don't have disk-ANN, or at least not yet, if ever. But we have various choices. There's flat, quantized flat, inverted file. This is IVF. There's HNSW, hierarchical, navigable, small world. There are all these different. Hopefully, in time, this will all normalize, and we'll have a standard set of indexing capabilities across all these engines. But it's the same concept. Here I'm choosing cosine, supporting the small embedding model up to 1536 dimensions. And just like the NoSQL API, the vectors will be just another property in your document, not a separate store, right? Although indexed separately, in this case using IVF. And then once everything is indexed, how do we search? We have a vector distance function in our SQL grammar for the NoSQL API. There I'm including the vector distance as a new property, comparing each vector in the collection or container with the query vectors and doing an order by so that the most relevant results bubble up to the top. You could refactor this as a subquery if you didn't want to invoke the vector distance function twice. It's a very, very small, very fast. It's a very small amount of overhead. But if you really wanted to be super optimal about this, you could create a subquery. You could do this as a correlated subquery that calls vector distance just once and then projects it as a property and orders by it. Okay. And if it was MongoDB vCore, with MongoDB vCore, there's its own kind of proprietary manner. There's no T-SQL language. There's just this object that you build out for your search, and you just supply. I mean, this is a reference to, on the previous slide when I defined the collection, it's a reference to that property. And that's what enables us to do a vector search in MongoDB vCore. There's a path to the vectors. All right, you saw this in the slide. It's how easy it is to get text embeddings. You point to the model, you input, if it's one, this is an array. If you put one element in, then you can hard code to get the first element out, but you can put an array of text items in there and you'll get back an array of embeddings. And I think that's enough for the slides. I think, we have couple more slides to get through before we jump into the demo. That is our solution overview, the solution that we're about to look at and work our way through. They're the full-blown solution for the movies database. We're going to store our data in Cosmos DB. And, starting off on day one, we have data in our database, but no vectors. Hasn't been vectorized. So we are going to, in bulk, retrieve documents from Cosmos DB, call Azure OpenAI, call that endpoint that we just saw in the demo, and return those vector embeddings and store them in there and have them indexed with disk-ANN. Then we're going to need an Azure function to monitor the change feed of our container so that as we add new movies, maybe we modify movies. Well, now the vectors have changed. We want our chatbot responses to always be up to date with the latest changes in our transactional database. So we pick up that change on the Azure function, and we just do the same thing to the change documents like we did with the initial data load. We return the vector embeddings and we update them back into the database. And with that kind of flow in place, we can implement our own AI assistant, where the user queries our AI assistant, which is a console application for this in this solution. That question can be sent on to Azure OpenAI to be vectorized, as we've seen. Those vectors come back, and it gets sent off to Cosmos DB for a vector search, as I showed in the slide. Right? It'll use the vector distance function to find and return the similarity results. We don't want to take the results that come back in their raw form and just dump them on the user. We'd rather pass them on to the OpenAI, Azure OpenAI, this time using the completions API to give us a natural language response based on the database results, but not straying from the database results, ideally. And then the user can see the answer. And that's our solution. And now we're done with slides, thankfully. I encourage you to visit this link and download the solution. The solution supports not just Cosmos DB for NoSQL and Cosmos DB for MongoDB vCore, as I've been discussing, but also Azure SQL Database, the Azure SQL Database Early Adopter Program, which is now no longer the Early Adopter Program. In the last week, they went public preview with native vector search, a native vector data type, and a native vector searching that will eventually come to Azure SQL Database, and it will eventually come to SQL Server 2022. But this even works with SQL Server 2022 using an ordinary column store index. And like I said, you can easily plug in your own domain data to this solution. There are instructions that show you how to do it. This explains the movies database scenario, but for each of the depending on your database, there's instructions how to set up the environment, how you need to configure OpenAI, and then in the case of Cosmos DB, just scroll down to that section. Yeah, just plug in a few values, update a few configuration files, and run the solution. So let me go ahead and start first by initializing our database. Now, this is our Azure function that is standing by, listening for changes. You can ignore these error messages. They're not going to negatively affect the functionality or the process in any way. It's just waiting for a change, right, as part of the demo. This is our console application. And you can see that I'm working with a database called RAG Demo. I'm working with the Cosmos DB for NoSQL edition, if you will, or provider. But like I said, this is a provider for MongoDB and SQL Server, Azure SQL Database. So let's go with Azure Cosmos DB for NoSQL. Our database name is RAG Demo, and we're using the text embedding 3 large model, which is 3072 dimensions per vector. Let me go ahead and initialize the database because I don't even have any data in my database. In the interest of time, I'm going to step over, drop in create database because it doesn't do anything other than create an empty database. But I will step into create container so you can see the code that you saw on the slide, just like you saw on the slide. I'm defining an vector embedding policy for cosine distance, 3072 dimensions, and an indexing policy where I've added a special vector index for disk ANN. My traditional indexes, by the way, is excluding the vector itself because there's no point in indexing the vector for traditional searching, right? The vector property. You just need the vector property index for your disk ANN index. So I'll just step over that. And I'm going to set auto scale at 10,000, which means a range of 1,000 to 10,000 in Cosmos DB. When you do auto scale, it's between 10% of this as the minimum and this is the maximum. So because we're going to do a bulk load of our data into this database, we'll create the container. And now we are going to get a file name. This is JSON. This movies JSON has all of our movies in it for the entire database. And if you're not familiar with Cosmos DB's bulk execution, the way it works is instead of calling await create item async, we call create item async without await, and that gives us a task which we load into a list, and then we kick it all off to run. Essentially maximizing the thread availability and the cores on your machine and maximizing the number of threads based on that, as well as saturating all the throughput, which was 10,000 maximum. So it actually populated pretty quickly, 4,486 documents. And now I'm bringing my throughput back down to 1,000, which is really between 100 and 1,000 because I'm finished with my bulk load operation. And now we're done loading our raw data. Let's flip on over to the portal. And I'll do a refresh. So this is the database that we just created. You can see I've got 3 others here. Those are already completely vectorized. This is a brand new database. Nothing is vectorized yet in this database. Let me plug in some SQL here. And let's see that I've got, yeah, we can look at the raw data. There's a lot of rich metadata in here about each movie, like the genres, the budget, the title, the overview, the languages, the production companies, lots of data, the production countries, the release date, the runtime, spoken languages, lots of rich metadata, but notably no vectors. I don't have any vectors yet. Okay, I've got 4,486 of these, as we saw when we do a select count. But how many do I have with a vector property defined? None at this point. So let's go ahead and kick off the vectorization process. I'm going to say vectorize data. Okay, and we're going to track the RU costs and the errors, but the main thing is that this method is going to vectorize data in the database. I didn't pass in any IDs, which means I want to vectorize everything. My SQL statement here is retrieves every document in the container, no where clause, right? And I'm going to get 100 at a time. So here I've got my first 100. These are the movies, the first 100 movies that I'm about to vectorize. Using the same technique we saw before when I vectorized one thing, but I'm going to vectorize now 100 things at once in one call to OpenAI. I don't have to make 100 calls to OpenAI. For each document, though, remember that I'm getting back vectors that are based on an analysis of the natural language text in my JSON. I want to remove things that don't contribute in any way. They're meaningless as far as the semantic meaning of the data in the JSON document of a movie, like the system properties. They're just going to, just for increased accuracy, I'm going to just strip those properties before calling out OpenAI. And this time I'm passing into the input the full set of 100. So when I call get embeddings, this time I should get back 100 items. And each of those items should have, let's see, first of all, yeah, I got back 100 items. And each of those items should have, an array of 3,072 vector values. From the large embedding model, there are 3,072 dimensions. So now I've got that 100 in one clip from one call to the Azure OpenAI service. And now when I save the vectors back, I'm doing the same bulk execution pattern that we saw initially, but just for this set of 100. First, I need to attach the vector from each response by OpenAI to each movie document, and then set up that task array for bulk execution to do the replace item. And then when I go back to Cosmos DB, to the portal, and I say, well, and I run the same queries before, how many? Yeah, there's 100, all right. The first 100, let's have a look at them. Here they are. They look like the same as they did before, but at the bottom, there we've got our vector. Every single one now has a vector. Every single one of these 100. Now, if I let it run, it's going to be the next 200 and then the next 200 and so on. And what I'm going to do now is I'm going to cancel this because this would take about 10 minutes. And I switch on over to one of my pre-vectorized ragdemo-3L. Coming back to here, this one here, right here. This is fully vectorized. All right, and there's my movies container. And the lease container is used by the change feed, which we're going to get to in a moment. All right. So the last part of this, the kind of wrap up, or if you will, the big payoff here is watching this chatbot work. So let me go on ahead and jump into my AI assistant. And basically, I've got a set of pre-populated questions. If I hit the letter A, it will automatically choose the next pre-populated question. I could hit the letter M and just type the question by hand. Let's go ahead with the first question. Please recommend some good sci-fi movies. So it's not vectorizing the question and running the vector search. That was the quickest part. Generating the response is dealing with the GPT completions. And what we can see is, yeah, we've definitely got some responses. Now we got 5 movies. We got 5 movies because in this demo, I've kind of hard coded this as the top 5, ordering by vector distance. So I'm always getting back 5 with the most similar on top. And even if the most similar are not that similar, I'm still getting back 5 just with a lower similarity score. So I'm always getting back 5 in the way this demo application is built out. So, and these are certainly science fiction movies, but I've got over 4,000 movies in my database, and there's a lot more than just these 5 sci-fi movies. I'm a Star Trek geek, like perhaps some of you are, and I'm more interested in Star Wars. So I'm going to say, what about Star Wars? All right, let's see what kind of top 5 response we get back now. So now we're looking at sci-fi movies that are limited to Star Wars. But again, if you're a geek like me, it becomes immediately apparent that we don't see the trilogy. The original trilogy is missing, and of course, nothing other than the original trilogy really counts, right? Certainly the prequels don't. Robot Chicken, we're not interested in that. I want the original trilogy. Actually, I'm looking for the original Star Wars trilogy. Now, look what I get back. I'm sorry, but it looks like the database doesn't have any matches. Now, of course, first of all, I did get back 5 results. Just none of them were matched to the original Star Wars trilogy. But then my Chat GPT completions prompt has instructed the completions response not to include database results that really aren't relevant to the user's question. You're going to see all this behind the scenes in a moment. But meanwhile, let's fix this, because how you got to hang your head in shame if you're hosting a movies database that doesn't include the Star Wars trilogy, right? And the whole point of this demo is to show how our chatbot experience updates in real time as our transactional database gets updated. So I'm going to back out of here and I'm going to run update data. And all that's going to do is load the trilogy in as 3 new movies, and they're going to be vectorized. We'll keep an eye on this Azure function. I'm not going to show the code for it because it's essentially identical to the code that we use to vectorize the initial data load. It's just running in an Azure function instead. So when I hit update database, yeah, 3 movies, 3 documents. Let's, it woke up. Yep. Star Wars, Empire Strikes Back, Return of the Jedi, generated vector embeddings. The Azure function went ahead and vectorized that data. So my database has been updated. The vectors have been updated. The AI experience is now going to change accordingly. So again, just asking for sci-fi movies is certainly not specific enough for the original Star Wars trilogy. So yeah, definitely some classics. 2001, right? My all-time favorite. But I'm missing Star Wars, so I'll say, what about Star Wars? And now I'm getting back 5 results. Yeah, there's it's including the original trilogy. Just by chance, I wasn't very specific about it. There's a top 5. Of the top 5, the first 3 are the trilogy, and then there's 2 others. But now I'm going to be, again, very specific and say, actually, I'm looking for the original Star Wars trilogy, and that gets vectorized again, of course. And now I'm getting back just those 3. Even though my vector search returned 5, the 2 of the 5 that were not part of the original, that are not matching the original Star Wars trilogy, were stripped out by the completions API based on the prompt that I gave it, which you haven't seen yet, but you're about to see. But before we see it, let's run through the rest of these automated questions. Do you know any good mobster movies? Little Italy, The Godfather. Okay, sure. These are definitely all matching. Any movies produced by Pixar? So there's a production companies array that's been vectorized. So this question is going to match on that. And by the way, there are things that you can do to improve the performance of the completion model, but this is for the best demo experience. I set the parameters just right. And as you can see, all of these are Pixar movies. Can you recommend movies in Italian? Yeah. Now, if I say, actually, I meant just comedies in that language without repeating Italian, like I showed you in the earlier demo, I'm appending each of these prompts. So I don't have to say, actually, I meant just Italian comedies. I meant just comedies in that language. I'm sorry, but it looks like the database doesn't have any matches for your request for Italian comedies, even though I just said comedies in that language. It understands the context and it seems to remember the conversation because I'm appending those messages each time. I love horror flicks. I sure do. Right. And there you go. I'm going to make one more point that you might have noticed a couple of places. Now, of course, I can't find one. Let's just do one more. Some good sci-fi movies. Let's just do one more of these. So you might have noticed a couple of things here. First of all, how upbeat and friendly. Right? It's got exclamation marks. It's telling you to enjoy it. I'd be thrilled. It's like, it's got a very upbeat and friendly demeanor. And none of them are happening now for some reason, but occasionally you're going to see little boxes show up that are emojis that I might not want to include. And you might also notice that it's always showing specific information from each movie: the title, the genre, and the overview, and the year, of course. Not of course, but it's showing title, year, and overview, and genre. The way this is actually, I've hard coded it for title, year, and overview. Whereas genre is configurable. I can remove genre and add other things, depending on how I configure the prompt, how I instruct the GPT model to produce the response. So let me go ahead and do update my configuration here. And you can see that the demeanor is upbeat and friendly. So I'm going to change that to serious and professional. Include details. Like I said, that's configurable. It's set to genre. Instead of genre, on top of the title, year, and overview, that is hard coded. I also want the production. I want to see the production companies. I want to see the runtime, and I want to see the similarity score. And finally, show internal operations, which is false. I'm going to set that to true so we can see some of the behind the scenes things going on, like the vector search and the chat prompts that the user normally doesn't see. Now let's go back into the assistant, and you can see everything in green is new stuff that we didn't see before, that the user isn't supposed to see, but it's behind the scenes chat prompt. So I have instructing my GPT model that it is a movie enthusiast, helps people discover films that they would enjoy watching. Your demeanor is, and that's what I plugged in from configuration. It used to be upbeat and friendly. Now I've changed it to serious and professional. I'm explaining what its role is. I'm explaining that its recommendations are not its own recommendations, but they're based on the results of a vector search against a movies database. And I'm being very important. I'm being very explicit here in instructing this thing. Don't embellish. It's better to apologize for having no matches and showing no results, right? And only show the following details of each movie recommendation. Title, year, and overview are hard-coded. But here I've removed genre and plugged in production companies, runtime, and similarity score. So let me go ahead and run it. And now, again, everything in green is behind the scenes. Here's the top 5 query that got run. It returned these 5 documents, the 5 sci-fi movies. But this is raw JSON, right out of the database, not the way I want to present it to the user. So instead, I create a new prompt, and I say, I tell the GPT model that the user asked this question, and in response to this question, we got these recommendations. And again, being very clear to guide it to limit recommendations to those returned by the database. Don't embellish with new information. And sure enough, it's not so upbeat and friendly anymore. Before, it was my best friend. Hey, you like movies? I like movies. I can be your best friend, right? Yeah. In this case, it's a little more like, based on your request for sci-fi movie recommendations, here are some. It's like serious and professional. Different demeanor might be appropriate for different applications, right? And we see that it is including the production companies and the runtime, just as I requested. So, kind of tailoring the natural language response from the vector search results by setting these prompts, right? By setting these prompts, something like really cool, like I'll do manual. I'll just do a manual question. These models are so deeply trained, they have references to pop culture in them, like rom-com. When I do this presentation in Europe, people in the audience don't get it. You know, I can't, it's hard to explain to them and say, yeah, in the US, you know, we have this slang term called rom-com, stands for romantic comedy. Oh, well, I think this part here is because of some of the changes I made in configuration. But here you can see that the results include from the vector search. For some reason, the completions model filtered out the results. But the vector search results return romantic comedy, right? And so on. Comedy, romantic, lovey-dovey sounds like a romantic comedy, right? So that's all really, really cool stuff. Let me wrap this up, since there are a few more minutes, with the DALL-E model. This might be a little bit underwhelming. The image generation capabilities of this model leave a bit to be desired. This is a technology that's still evolving and growing. It's going to get better, but let me oops, I didn't mean to end the application. Let me start it one more time. And let me do update configuration and say show internal operations to true again. You want to see what's going on behind the scenes. And I'm going to say generate poster image true. This is a bit of a gamble because sometimes I get error responses for content violation from responsible AI. The unpredictable nature of this technology really, keeps you on your toes. So you never get the same exact response twice. I'm going to go ahead now and update configuration. I set generate poster image to true. So let me do sci-fi movies. So there's my top 5. Here are the raw results from the database. Now we're going to get a nice natural language response like before. But now, in addition, I'm planning a movie night discussion event. Make a collage poster depicting one image based on each movie. And here are the database results. I want an image generated based on the database results. And of course, I got redacted. That's what I was warned, a content policy violation. It has to do with copyright. So let's just try the next one. What about Star Wars? I'll either get the same redacted error or I'll get an image where they've obfuscated. All right, let's see what happens when it tries to generate the image. I often get it when I try the horror flicks one because it's trying to generate images of bloody violence and then it says it can't do it. This one seems to be working, but of course it's going to be obfuscated. And like I said, this is not perfect, but there, it generated an image. It doesn't say Star Wars anywhere for copyright reasons, but this is like some kind of science fiction Star Wars-ish type of movie poster, similar to the way I asked it. Of course, the English spelling is all messed up. But this kind of gives you an idea that you can have images then generated based on the results as well. As opposed to, I'm not talking about images that you may already have stock images in your database of your product catalog. Obviously, you can retrieve those with conventional means, but you can also dynamically generate images as well from database results using the DALL-E model, where it's really as simple as this here. Right, I'm here in the AI assistant base class. So this is shared by every provider. And here I'm generating a poster image. I build the prompt, which is just that natural language text. And yes, it's another call to OpenAI, but this time we're calling it get image generation and passing in the name of your DALL-E model. You can control the quality and the size of the image to some extent. And that's that. Again, I encourage you to, if you have a look at the solution, the way it's constructed, or organized, I should say, in the RAG solution folder. This is the front end. This is where most of the back end stuff works. And this is a custom project where you can plug in, right? This has nothing to do with movies. It's just products for an e-commerce scenario. Maybe I have recipes or maybe you have a legal database with legislations. It could be anything, really anything, where you inherit from the necessary base class and provide very, very little additional information, as you can see, in order to get up and running really quickly, right? Just your proper vector search. And then when you, and that's really it if you're dealing with Cosmos or Mongo, because those are all schema free. If you're dealing with SQL Server, then these 3 projects here are database projects that have the defined tables and stored procedures that are able to perform the same, provide the same functionality using those database backends as you saw today for Cosmos DB. Furthermore, Azure SQL Database has the unique capability of calling Azure OpenAI directly rather than doing it from C#. You can pass the question to the database. The database, in the case of Azure SQL Database, can call OpenAI by calling SP invoke external REST endpoint or something like that, and get the vectors, without that having to be done in C#. So all of this goodness is out there for you to check out and enjoy. And again, there's the link. I think I managed to pull it in under an hour, 1:59 up. There we go. There's the turn of the hour. And with that, I'm
So much we got to today. Thank you so much, Lenny.
There are a few questions if you're able to go over. I just noticed.
Yeah, I got a few questions here. Let's see what we can do. So Greenig, I think it's Greenig, wants to know, the sample only talks about Azure OpenAI, but I understand that the Phi 3.5 model can be used.
Yeah, if it can, it is a different implementation, right? I mean, this is, you can also use Python and LangChain, right? There's many different ways to achieve RAG. This solution is tied to Azure OpenAI. And by the way, I should say, the C# code samples that I showed you just now with Azure OpenAI, they're using a preview version of the NuGet package that has just been released. So there are breaking changes there, which I'm working on updating in my solution now. But it is, yes, my solution is strictly for Azure OpenAI. If there are other means that you can access to vectorize your content, the RAG pattern doesn't really change in any way. You're just calling a different service to get those vectors. What matters is that the vectors in the database must be generated from the same model that you're using to generate the vectors for the question. Obviously, naturally. Maybe it's not so obvious, but when you kind of see how they align, how the dot product does that element-wise multiplication, it's relying on the vectors emanating from the same model, whether it's Azure OpenAI or another source.
Great. We got time for one more question. Jeff wants to know, say Netflix had a chatbot and chat memories were vectorized and saved to Cosmos DB. Is there a pattern for sharing those vectorized memories with, say, their AI-based movie recommendation engine by a user?
Hi, Jeff. So there, I don't know about vectorizing the conversation results or the chat completion results, but my solution does not persist any conversations. So that is certainly something that you can extend your solution to cache and store conversations and completions, perhaps cut down on the need for additional API calls if you can rely on cached previous responses and recall previous chat history once the conversation comes to an end. But I didn't quite understand the part of the question about vectorizing the results themselves.
Well, that gives the good lead into saying that how can people contact you if they want to follow up on the questions that they may have asked?
Oh, sure. Well, I can put my email into the chat right now, and
sure.
Yeah, feel free to email me.
And I would imagine they can find you on LinkedIn as well.
Yeah, for sure.
Great. Well, while you're doing that, I'm going to bring in Askia to help kind of wrap us up with what you, the viewer, should be doing now.
Yes, thank you, Jay, and thank you, Lenny. Excellent session, and we definitely would appreciate any feedback that you have to offer. So, Jay, so kindly put the the survey link on the screen. So, if you want to do that, please just use the event code, which is 23562. And until then, for me, we will see you next time.
Yeah, I know, Askia. We've got another one next month. I'm really looking forward to it. We always try to make sure people are part of these. And just a reminder, if you have not and you would like to present, go to that link right down there. You can submit your session. Just like Lenny, you can share what you've learned about Cosmos DB with our community. All right, cool. So, Lenny, I want to say thank you so much for today. Another wonderful session that we've been able to hear from you. And I know you've got all the time, you're doing new presentations across the world. Any place interesting coming up?
Orlando next week. I just did Netherlands a month ago. I've got some user groups, small venues. Yeah.
All right, great.
Vegas coming up. Yeah.
Yep, everybody keep your eyes on Lenny's LinkedIn. You'll be able to find out what he's up to, when he's up to it. Like I said, Lenny, thank you so much. And
Thank
I'm really
you, Jay.
looking forward to one of these. I know we'll probably get another one at some point. So thanks a lot.
Yeah, I look forward to the next time. And thank you again for inviting me. Have a great day, everybody.
Everybody, we're going to give you the big wave goodbye. We'll catch you next time. Thanks for joining us at the Azure Cosmos DB Global User Group. Have a great day and take care of yourselves. Bye now.